Good morning, students. Your physics teacher Hassan Darwish with you. Let's continue on this video. This is video 4. The application on conservation of linear momentum. Last video we did recoil of a Canon. Now we study collision and explosion. You know that collision and explosion are two opposite situations or phenomena. We can neglect the external forces acting on the system during collision or explosion. Why? Because internal forces between the bodies are much bigger than any external forces. Let me show you here. Here the force exerted by the gun on the bomb, as you know, is much bigger than the weight of either the bomb or the gun, right? Very big force, but it is internal. Is that true? Because this was our system. So the force exerted by the gun on this bomb is much bigger than the weight of the bomb. Second, duration of collision or explosion is very small, so that what? External forces have no big effect. Hence, during collision, the linear momentum of the system is conserved. We apply this directly, clear, without any justification. That's why I can say linear momentum of the system after collision or explosion is equal to the linear momentum of the system initial, means before collision or explosion. Let's do a direct application. Here in this example, we have a collision along a straight line, say along x prime x. We have two air packs, A and B, masses 300 gram and 500 gram, move opposite to each other on an air table with velocities 2 meters per second and minus 2 meters per second. Look here, this is an algebraic value of the velocity, and this is algebraic value of the velocity, because you know algebraic number could be positive number or negative number, right? So here, because the velocity v2 as a vector is opposite to x prime x, which is a positive sense, the algebraic value of v2 is negative. Notice here. Also, the vector v1 has the same sense as the positive x prime x, so its algebraic value is positive. Okay, that's the meaning of algebraic number. Just after collision, pack B rebounds. You see, rebounds with velocity 2 meters per second. Means after collision, this B moves back along positive x-axis with v prime 2. You see, it is positive. That's why this vector positive, like x prime x. That's why this is positive number. Okay? Part A, determine the velocity of A just after collision. Good. So how do we think of this exercise? As I said before, during collision, the linear momentum of a system is conserved. Let me write it here. You can directly write it, okay? So during collision, the linear momentum of the system is conserved. And notice here, as I said, linear momentum of the system. System means both bodies. Be careful, both bodies. The linear momentum of A alone not conserved. Clear? Because the sum of forces on A is not zero. Also, the linear momentum of B alone is not conserved. Clear? While the linear momentum on the system together is conserved. Here it is. Why? Because this is our system. Okay, let me draw it clearly here. This is our system, I mean the two pucks. This is B, and this is A. Okay? So here collision. Okay? Sorry. This is A. So during collision, there is a force exerted by A on B. You see, it's very big force. A on B. And also, at the same time, according to the principle of action and reaction, or in Newton's third law, there is a force exerted by B on A, right? The two forces, as you see, equal and opposite. But don't forget, this is our system. This is our system. Okay? It means what? The two forces here, FA on B and FB on A, are internal forces. Clear? They are not external. And so the sum of forces is zero external. So the linear momentum of this system, as I said, is conserved. So P of the system before collision, I mean, emphasize here on system. Okay? Before collision is equal to P, which means the linear momentum of the system after collision. Okay? Okay, but the system consists of two objects, A and B, right? So this means that M1 V1 for A plus M2 V2 for B. Usually students commit a lot of mistakes while applying this rule because they apply M1 V1 alone and M2 V2 alone, which is not true. That's why I put it here in a big bracket. This is before collision. This is the linear momentum of the system before collision. Our system consists of A and B. And this is equal to M2 V1. Let me call it prime. Prime doesn't mean derivative. It means after, okay? Plus M2 V2. Also, let me call it prime. But this is not the derivative. Be careful. It means after collision, okay? So, of the system after collision, okay? Or finally. Right. So let's replace M1 V1, but I cannot replace number so far because of what? Because this is a vector relation. I have to get rid of the vector. Now let's look at the exercise. Here we have x prime x, positive sense to the right. So let's change the vector into scalar number. I mean algebraic number. So this is M1 V1. Be careful about this step. You know it from mathematics. M2 V2. But be careful. Here. Here vector V1 is along x prime x, and this is unit vector I. Okay. Here V2, this is unit vector I. V1 and V2, notice here, could be positive number and negative number. I left them in algebraic value. Equal M2, sorry, here there is M1. M1 M1 V1 prime, and this is the unit vector I. Why? Because the collision takes place along x prime x only, plus M2 V2 prime I. Now you can cancel the unit vector I as you see here, right? You can eliminate I while you keep the values of V1, V2, V1 prime and V2 prime in algebraic number. I mean, the quantity could be positive number or negative number. Let's replace the number here, the values. M1 is given how much? M1 is 300 gram, M2 500 gram, okay? V1 2 and V2 minus 2. Good. So here 300 gram means 0.3 kilogram into V1, which is how much? 2, right? Plus M2, which is 500 gram or 0.5 kilogram, and notice here its minus is negative. That's what I mean by keeping V1, V2, V1 prime and V2 prime in algebraic values. Okay, you replace here the positive number or the negative number. Depends whether it is on the positive x-axis or negative x-axis, the vector. So here 0.3, while V1 prime is unknown. We need to calculate it. Plus 0.5, and it rebounds, as he said, with 2 positive number. Remember? So let's do the calculation. We get V1 prime equals 0.6 minus 1, right? 0.6 minus 1 minus also 1 here. Okay, all of it divided by 0.3, and then we get here minus, I think, 1.4 over 0.3, which is approximately 4.7, and notice here the answer is negative, meter per second. Notice here the minus sign. You see, minus sign implies what? Implies A rebounds after collision. A rebounds, okay, just after collision. Okay, any problem? Good. So in the next video, I'm going to apply the collision between any two objects along x prime x in general, okay? And also we are going to study the type of collision. Take care, goodbye.